At number 2, we have an event with the potential to kill 75% of all living things on the planet. We know this because it's happened before. An asteroid strike. We are constantly bombarded by debris left over from the formation of the solar system. We travel through fields of them on a reliable timetable, and almost all of them are too small to make it through the atmosphere without being entirely destroyed. Once in a while, though, a large meteor does make it through. Millions of years ago, in the far reaches of the solar system, a 55-foot wide, 10,000-ton chunk was knocked off an asteroid and sent spinning onto a collision course with Earth. In 2013, it completed its journey, entering the atmosphere at 41,000 miles per hour and exploded above Siberia with the force of 30 Hiroshima bombs. It was a baby. 66 million years ago, the Chicxulub impactor hit what is now Mexico. It was an asteroid 6 to 9 miles across, weighing 2 quadrillion pounds. The shockwave from this 100 million megaton blast destroyed everything for miles in every direction and sent a mile-high mega tsunami racing around the world. Impacts this intense deform the Earth and have the potential to alter its orbit. Every living thing on Earth would have felt the Earth move. The sound of the explosion would have been heard for hundreds of miles. As billions of tons of pulverized rock reached the atmosphere, the planet descended into an impact winter. As the rays of the sun were blocked out, plants began to die. The food chain collapsed. The dinosaurs, who had ruled the planet for almost 200 million years, were wiped out, along with 75% of all living things on Earth. It has happened many times before. It will happen again. The result of an impact of that magnitude hasn't changed over the last 66 million years. But unlike the dinosaurs, we have the ability to plan. If we saw the asteroid coming, and NASA is currently monitoring around 80 that are almost a mile long, we might be able to divert it away from us. A tiny deviation in trajectory can transform a hit into a miss if it's done far enough away. NASA's recent DART mission managed to do just that in 2022 with Dimorphos, the satellite of an asteroid that can pass at approximately 6.8 million miles from Earth. This technology is in its infancy, and we potentially have millions of years before we have to deal with this. So, it might never be a problem. However, if we saw it too late, if our efforts failed, or if the asteroid was simply too large, then for the vast majority of us, the end would come quite abruptly. Whether from the impact, the shockwave, the earthquakes, or the mega tsunamis, we would see a flash, feel the ground shake, hear the loudest sound in human history, and then we would be gone. Those who survived the first day would likely not survive the centuries-long winter. The last remnants of mankind would slowly die out on a desolate planet. The planet will go on without us, and indeed, all the other animals. It will reset again as it did after the dinosaurs. The threat from asteroids is both immense and inevitable, but the fact that it is potentially tens of millions of years away means that it may not even be a threat to mankind by the time it arrives. At number 1, we have the definitive end of planet Earth, and it will end where it all began, at number 10 with our local star, the Sun. All stars are giant nuclear reactors, fusing hydrogen under immense pressure to turn it into helium. The heat we experience is the explosive energy being released from this fusion. Like anything that uses fuel, stars have a built-in expiration date. A point at which their fuel runs out. Their reactions can no longer continue, and they die. Happens. Everything within a few billion miles is obliterated. If a supernova were to happen within 25 light years of Earth, about 147 trillion miles, then we would all probably perish as the protective layers of our atmosphere were blasted away by the cosmic waves. Fortunately, that's unlikely to happen. What will happen is that our sun will start to burn up all its hydrogen, start to swell, and get hotter and brighter. This is not going to be a quick death. In about 1.3 billion years, life on the surface of Earth will be impossible because of the heat and humidity. At about 2 billion years, the oceans will evaporate, and Earth will look more like the Moon or Mars. Our lush green and blue orb erased from existence. At this point, it would be fair to call planet Earth dead. After another 3 billion years, about 5 billion years from now, the sun will have used all its fuel in its core, and hydrogen fusion will stop. Gravity will take over, and the core will compress dramatically, causing a massive spike in temperature as the sun begins to fuse helium. The outer plasma layers of the sun will, over the course of tens of millions of years, become a red giant, expanding through the solar system to 200 times its current size, consuming the inner planets one by one. Earth will be completely gone. After about 1 billion years as a red giant, all the helium will have been consumed. The core will cool, and the red giant will become a white ball, a white dwarf. Our small corner of the Milky Way will be dark for the first time in 10 billion years. This is how the Earth will end. It is inevitable, but it will not happen until long after we are gone. Since the formation of Earth billions of years ago, the only certainty has been that one day it will once again become dust. Mankind is the first animal to be aware of this. We're the first to have an understanding of how it might happen, and the only ones to have any hope of averting it. That we have spent so much of our time and resources increasing the potential causes and accelerating the timeline is a tragedy. It is in our power to prevent nuclear Armageddon, pandemics, and even climate change. But somewhere in the galaxy, perhaps millions of years from now, there could be a rock the size of Manhattan heading straight for us, destined to end all life on Earth. The question we have to ask ourselves is, will there still be life here for it to destroy?